Today is 24th March 2025. I'm going to talk about data mining, how to do basic EDA, data analysis. First, then we should know about data. What things we should analyze about data would be our first job. I will go through some statistics, and then after that, I will go through today is March 2025. Data, I will talk about EDA, data analysis, and we will talk about first statistics and what we can use in data mining. For data analysis, basically, first we should understand data. First, we should understand about data type, whether it is numerical or categorical or text extra. Numerical or categorical text or so on. And for data, there can be missing data. If there's missing data, you can do deletion or imputation, which is imputation is you are assuming mean or mode or median. And you can also do interpolation. In interpolation, also there is various methods in interpolation. And for identifying outliers, we can use Z-score. Or we can use interquartile rate multiply plus or minus a certain value. I will talk about this more. So and we should also check the distribution. For mean, you can easily find it as mean u equals to sigma xi over n. And mode is the frequent value. And for normal distribution, mode, median, mean is equal. Every mode, median, mean is here. But in left skew case, it's left skewed and right skewed. In this case, there will be mean here, median, mode. In right skew case, mean will be most high, which is mean usually affected to the tailed value. And for sample, for standard deviation, we use x bar square over n minus 1. When we use n minus 1, first reason is because degree of freedom. If you ask why degree of freedom, okay, that's actually because we need unbiased estimator, which is E theta f equals to theta. I'm a bit curious how these are related to each other. We can figure it out next time. And if I keep going, or for the spread, we can use standard deviation, but we can also use range max x minus min x, or IQR, which is Q3 minus first quantile, third quantile minus first quantile. In oh, in oh, number of samples when number of sample is positive, let's say the number of sample is 1, 2, 3, 4, then this will be Q2, and here in the middle will be Q1, in the middle will be Q3. As number of sample is 1, 2, 3, 4, 5, then here will be Q2, and this will be Q1 and Q3. And I talk about skewness here, skewness display. Skewness we can calculate it as R1 equals to e to the x minus mu over sigma cube, or in sample case, we calculate it by mean over cube of standard deviation, which is minus 1. That's a bit complicated. Oh, sample skewness. And there is also positive skew. It was left skew, and for positive skew, there is also positive and negative skew. If positive skew, this was left skew, and there's positive skew, which is mode, median, and we call it the positive skew. And for negative skew, mean, median, mode. A negative skew, it seems like negative skew equals to left skew. Negative. Probably this value will be negative. And for kurtosis, it is about how much tiltedness is thick compared to normal distribution. We use it as the expectation value of x minus mu sigma over to the 4. And for excess kurtosis, we call it Fisher kurtosis. We minus 3 this, and whether if it is positive, then the fish has big value, then has heavier tail and sharper peak than normal distribution. Heavy and sharper peak. Heavier tail and sharper peak. Then we can basically use histogram And for visualization, it's very important unless we can't understand the data. There is histogram, box plot, pair plot. We use pair plot for usually panel data set. Box plot is what we usually with IQR, interquantile range and things. And also there's correlation. Correlation is very, very important concept in bivariate case. For the Pearson correlation, if I use the formula, the definition of correlation is if x increase and if y increase, then correlation will be 1. If correlation is 1 or -1, then every observation is in certain line. It is very important. Every observation is in a line. If not, here there's linear algebra arise. Linear algebra come out. If this is case like there's number of variables and constraints are equal, but if there are more variables, if there are more variable than constraints, or if there are more constraints than variable, then in this case it will be 2/3 log case with x, y. In this case, we use your method. Square method. So this is very important part that is connected. That the concept is connected with linear algebra. And so for the correlation, there's Pearson correlation, which is x minus xi bar and y minus y bar's summation divided by x minus xi bar's squares root multiplied by y minus y bar's square root. And for there's Spearman rank correlation, which is measure the rank. So when there is 5 variables, then there will be rank in between them. We calculate that rank. And there's also Kendall's tau, which is rank correlation and Kendall's tau. Rank correlation and Kendall's tau. For rank correlation, if there is for x, which is 10, 20, 30, 40, 50, and y, which is 40, 30, 50, 20, 50, then rank will be 1, 2, 3, 4, 5, but y's rank is changing. Then we can calculate the distance in between them. Then we're using distance square and number of variables. So we can calculate it. Which is distance square divided by number of variables and square minus 1. In Kendall's tau case, we calculated by c minus d over n minus 1, which is related with number of samples. In this case, we check, let's say there are x, y, which is 5 pairs, let's say 1, 2, 3, 4, 5. 4, 3, 5 to 6. And if we pair this, one pair to pair, 5 pair, compare all of pairs each other, then there will be 10 pairs comparison. There will be 10 pair comparison. 5 pairs compare each other, then there will be 10 pairs. And we will check from 1 to 4 to 2 to 3, it increases. It decreases, but X is increases, but Y is decreases. Then we call it discordant relation. Discordant first, discordant relation. But in 1, 3 increases, and when 4, 5, it also increases, then it's concordant situation. So we calculate the number of concordant pairs each other, and number of discordant pairs each other to calculate the result. And now we'll move to missing values. So there what we did was imputation, and maybe we can delete it, or we can do KNN approach. We can also do KNN approach, or we can do regression imputation, or we can do multiple imputation mode generate it. And for the finding outliers, there is point outliers, or there is collective outliers. We can remove it, or we can using Z-score to find it, detect the outliers, or we can use IQR. Like there is lower inner fence, which is Q1, Q3, Q1 minus 1.5 IQR, or Q3 plus 1.5 IQR. Or there's outer fence, which is much have big range, Q1 minus 3 IQR, or Q3 plus 3 IQR. So if you are out of some value are out of it, then we regard it as outliers, which is these things are using box plot method. So we can also use scatterplot for correlation, box plot for IQR, scatter plot for box, and pair plot for clusters, pair plot for clusters or trend, cluster, trend, and histogram for distribution. And based on it, we can do feature engineering, which is extracting day of the week by quarter or by season. Spring, summer, winter, autumn, we can fit, and we can, based on it, we can do feature transformation like using PCA for dimensionality reduction or reduce skewness. And another thing is, if it is categorical variable, we can do one-hot encoding. But when you do one-hot encoding, you can't find correlation between similar words. In NLP case, hotel and motel has similarity, but one-hot encoding can't find it. So we do word to vector, or other case, we do label encoding, or we do ordinal encoding. If low, medium, high, then we can encoding it as 1, 2, 3. Or if it is red, blue, green, we can encoding as 0, 1, 2. And for scaling and normalization, there is min max scaling, which is there is certain value x prime. Min max scaling, max scaling. If there is certain value, then we will change it to x minus min, or x max minus x min. If x is maximum, then it will be 1. And if x is minimum, it will be 0. And we can do standardization, or we can do robust scaling, which is when you do standardization, you use mean and sigma, but we can change it to median and intercontinuum number, then we can reduce the effect of outliers. And when you do feature engineering, you should compare the different unit effect. And when you use gradient descent-based model, you will use local minimum. And maybe you can use distance-based model like KNN or clustering algorithms. You can do other things. And next time we will come back with code. Thank you.